Hey guys, today we're going to look at how we use rational functions to solve for applied problems, meaning word problems. So what we're going to do within this lesson is we're going to dissect each of these word problems and see how we can take the scenario that's given and translate it to a rational equation. So first we're going to start off with work. Now work rate problems usually involve when two people are trying to help each other to finish a single job. Now here I have these two equations. The amount of work that is completed is equal to the rate at which they are completing it times the time. But for most of these questions, we are going to be asked to find a rate, or we can write equations that represent rates. And rates, if we just divide time to both sides, is equal to the work that is completed divided by the time. So let's look at this problem. It says here that Jane can clean the garage in 3 hours, but it takes Angie 4 hours to do the same job. How long would it take them to clean the garage if they work together? So I have here kind of like a guideline on how you can approach this type of question. First, we would have to set up an expression for both Angie and Jane's rate. So let's start with Angie. It says that it takes Angie 4 hours to clean the garage. So her work is to clean one garage, so 1, over her time, which is 4 hours. Jane takes 3 hours to clean the garage. So that's again 1 garage in 3 hours. Now it says, how long would it take for them to clean the garage if they worked together? So if they work together, that means that Angie's rate plus Jane's rate would have to equal to a new rate, or rather, the rate of them working together. So if I add 1 over 4, Angie's rate, plus 1 over 3, which is Jane's rate, that's going to equal to the rate of them working together. So again, they're still cleaning that one garage, but we don't know how long it would take them. So we're going to use X. And that's why it says here, let X equal the number of hours it takes for them to work together. And here I even wrote it again just to translate this. Since they are working together, the sum of their individual rates equals the total rate. So this is the equation that we have. And as you can see, we are trying to solve for the time that it takes for them to clean it together, which is exactly what the question is asking us to do. So once you've set up your equation, then we use whatever method that we learned in the past to solve this rational equation. Here, since we have addition, we're going to need an LCD. Keep in mind that the LCD is found by multiplying all of the denominators together. So if I multiply 4 times 3 times x, that gives me the LCD of 12x. So I'm going to take my equation here and I'm going to multiply the whole thing by 12x. So 12x times 1 over 4 plus 1 over 3 is equal to 1 over x. Let's distribute. 12x times 1/4 is the same thing as saying 12x divided by 4, which is 3x. Plus 12x times 1/3 is the same as saying 12x divided by 3, which is 4x. Equals to 12x divided by x. That means that the x's would cancel and we're left with 12, sorry. So now we add this together. 3x plus 4x is 7x is equal to 12. And then divide the 7. And we get that x is equal to 12 over 7 hours. But of course, we don't really talk like this, right? We don't say, oh yeah, it took me 12 over 7 hours. We actually would divide it. If you divide 12 by 7, what you would get is 1.7 hours. So this is how long it would take them to clean the garage together. Let's try a couple more examples. We have here that Bill can finish a report in 2 hours. Maria can finish the report in 4 hours. how long will it take them to finish the report if they work together? So this is the same thing as what we did in the previous example. We have to write the rate for Bill and the rate for Maria. And since they are working together, we add them together, and that's going to equal to the new rate. So Bill finishes the report, that's his work, one report in 2 hours. Plus Maria, who finishes that same report, so one report, in 4 hours. And if we want to know how long it would take them to do this together, that would equal to 1 over the new time, x. So now we need the LCD. Now you can most definitely do 2 times 4 times x, which is 8x. However, think about when you're finding a common denominator with the numbers, you want to find the least common denominator. I can just use 4 since 4 is both divisible by 2 and 4. So my LCD would be 4 and then x. Now if you use 8x, that's acceptable as well. But I'm going to use 4x since that is technically the least common denominator. So now we're going to multiply that with the entire equation. So 4x times 1/2 plus 1/4 is equal to 1 over x. We distribute, remembering that these fractions mean that we're dividing 2, dividing 4, dividing x. So 4x divided by 2 is 2x, plus 4x divided by 4 is x, is equal to 4x divided by x, which is 4. So 2x plus x is 3x, is equal to 4. And then we divide the 3. So x is going to equal to, if you actually divide 4 by 3, you get 1.3, and the units here are hours. Now let's look at a more complicated example here. It says it takes Livia 7 more hours to paint a kitchen than it takes Hank to complete the same job. Together, they can complete the same job in 12 hours. How long does it take Hank to complete the job if he works alone? So here we're trying to figure out the time it takes Hank to work. So we're going to make x equal to Hank's time, since that's what I'm trying to figure out. Now let's write an expression for Livia, let's write an expression for Hank, and then we'll create the equation. So here it says that it takes Livia 7 more hours to paint a kitchen than it takes Hank. So the kitchen, that's the work, one kitchen. Livia takes 7 more hours than Hank. So that means that her time is Hank's time plus 7. 7 more hours than Hank. Now they're working together. So we're going to add Hank's time, Hank's rate. So Hank completes the painting the kitchen, so one kitchen, in X time. And we're going to make this equal to the same kitchen over together. It says here that it takes them 12 hours. So 1 over 12. So this would be my equation. This is Livia's rate plus Hank's rate is equal to the rate together. So now it's time to find the LCD. Here we just multiply x plus 7 times x times 12. So my LCD would be 12x times x plus 7. So we're going to multiply the entire equation by the LCD. So 12x times x plus 7 plus 1 over x plus 7 plus 1 over x is equal to 1 over 12. Now we distribute. Now just in case, if you have a hard time on seeing what would cancel, I'm just going to do this the long way where I'm going to distribute everything Write everything out and then cancel. So 12x times x plus 7 times 1 over x plus 7 would be 12x times x plus 7 times 1 all over x plus 7 plus 12x times x plus 7 times 1 over x is going to equal to 12x times x plus 7 times 1 over 12. Now we can start canceling. I can cancel the x plus 7's here. I can cancel the x's here. And I can cancel the 12's here. So let's see what we end up with. Here we have this 12x times 1, so just 12x. Plus, then here we have 12 times x plus 7 times 1, so that's just 12 times x plus 7 is going to equal to x times x plus 7 times 1, so x times x plus 7. Now we're going to distribute everything and combine like terms. So we're going to distribute this 12. So we get 12x plus 12x plus 84. And this is going to equal to x squared plus 7x. Now in this case, we end up with a quadratic. So remember, when you have a quadratic, you want to make the equation equal to 0 and then factor. We can first combine these two. This is 24x plus 84 is equal to x squared plus 7x. So I'm going to move everything here on the left side over to the right with the x squared, so that way we can factor. So I'm going to subtract this 24x, and I'm going to subtract the 84. And we end up with the quadratic x squared minus 17x minus 84. And we're going to make this equal to 0. And now we have to factor. Now the two numbers that multiply to give us negative 84 and add to give you negative 17 are negative 21 and positive 4. So our factors would be x minus 21, x plus 4. Make it equal to 0. And now we solve for x. So we get that x is equal to 21 and negative 4. Now you got to decide which one of these is correct, because it doesn't take Hank 2 different times to complete one job. It's only one time. Now again, here we have that x is Hank's time. Time cannot be negative because there's no such thing as negative time. So this is not the answer. And therefore it takes Hank 21 hours to paint the kitchen on his own. Now we're going to have a look at distance and speed problems. Now you can solve a distance and speed problem using the same process as we just did with work and rate problems. The relationship between distance and speed is such that distance is equal to a rate times time. Now most of these questions involve us trying to figure out the time. So we can use this relationship to write an equation for time. If you divide the rate to both sides, you get that time is equal to distance divided by rate. And just in case, you can also write an equation for rate. If you divide time to both sides, we get that rate is equal to distance over time. So depending on what the question is asking, you will either use this time equation or the rate equation. Now let's look at this example. It says here that a speedboat can travel 32 miles per hour in still water. It travels 150 miles upstream against the current, then returns to the starting location, traveling downstream. The total time of the trip is 10 hours. What is the speed of the current? So a couple things to keep in mind here. You're going to see words like upstream and downstream, or against the wind or with the wind, things like that. Upstream means that you are going against the current. Think about like when you're going to the beach, right? I don't know if, when you're walking out into the water, the waves are coming at you. So when you're walking in, it's as if you kind of like you're trudging against those waves. So you're going slower versus when you're getting out of the water, the waves push you out. So you're going faster trying to come out. So that's what upstream and downstream is. You're going to go slower when you go upstream because of the current. And you're going to go faster when you go downstream because you're going to travel with the current. So let's see how we can dissect this. First, if you trying to figure out your variable, we look here at the question. It says, what is the speed of the current? So I'm going to make x equal the speed of the current. Now, let's write an expression for the speedboat going upstream and then an expression for the boat going downstream. If the boat is going upstream, the time that it takes is the distance. So it says 150 miles upstream. So that's the distance over the rate. And it says here that the speedboat travels 32 miles per hour in still water. So that means that that is like what it would read in like the speedometer, right? Like the setting that you put your speedboat to go. So that means that if it's going upstream, it's going 32 miles, but minus the speed of the current, because the current is going to slow it down. That means that when the speedboat is going downstream, it says here that it returns to the starting location. So the distance is also 150 because it's going back to where it started. And the speed of the speedboat is 32, but now it's going with the current. It's going downstream. So that would be plus the speed of the current. So all of this represents time. So in order to write our equation, think about what this means. The time the speedboat is going upstream plus the time that it takes to return is going to equal to the total time of the trip. So upstream plus downstream is equal to the total. So 150 over 32 minus x plus 150 over 32 plus x is going to equal to the total time, which says here is 10 hours. So here we're going to do the same thing that we've been doing. We need an LCD. If you look here at the denominators, we only have these two. So my LCD is going to be 32 minus x, 32 plus x. So I'm going to multiply my entire equation by the LCD. So we have the 32 minus x times 32 plus x times 150 over 32 minus x plus 150 over 32 plus x is going to equal to 10. And now we distribute. Now when we distribute this LCD to this first fraction, those 32 minus x's would end up canceling. So that means that the only thing we would multiply is the 32 plus x times the 150 plus. Now when we distribute the LCD to the second fraction here, the 32 plus x's would cancel, and so we're only multiplying the 32 minus x times 150. And that's going to equal to the 32 minus x times 32 plus x times 10. So now we're going to distribute everything and solve. When we distribute 150 here, 150 times 32 is 4,800 plus 150x plus. Now I'm going to distribute this 150 to the 32 minus x. Once more, 150 times 32 is 4,800 minus 150x. And that's going to equal to, now we have to multiply these out. So I'm going to distribute this first. the 32 minus x with the 32 plus x, which when we multiply, we would get 1,024. That's 32 times 32. Then plus 32x minus 32x minus x squared. And then this I have to multiply with the 10. Now here, these 32x's will cancel. Here, the 150x's also cancel. So I'm going to simplify this a little bit. We have 4,800 plus 4,800, which is 9,600, is going to equal to 1,024 minus x squared times 10. So now we can distribute the 10. So we get 9,600 is equal to 10,240 minus 10x squared. Now this is a quadratic, however, it is by itself, so we can just solve for x by subtracting, dividing -10, and then square rooting. So we're going to subtract this 10,240 to both sides. And we get -640 is equal to -10x squared. Divide the -10, and we get that 64 is equal to x squared, and then square root both sides. So we get that x is equal to plus or minus 8. Now remember that we are looking for the speed of the current. Speed will be positive because, we don't really say anything as having negative speed. So that means that our correct answer here would be positive 8. So the speed of the current is 8, and then we have to look at our units, which is miles per hour. Let's look at another example. Here we have a question that involves wind, which we can use the same process to solve the problems involving current as we do with wind. So going against the current is the same thing as going against the wind. Going with the current is the same thing as going with the wind. So we can still set up our equations in the same way. It says here that a plane flies 910 miles with the wind. And in the same time, it can go 660 miles against the wind. The speed of the plane in still air is 305 miles per hour. So let's see how we can figure this out. It says, what is the speed of the wind? So I'm going to make x equal to speed of the wind. So it says here that the plane travels 910 miles with the wind. So remember that time is equal to the distance divided by the rate. So the time it takes this plane to go with the wind is the distance, which is 910 miles, over the speed of the plane, which is 305, with the wind, so plus x. And it says that in the same time, so that means that it's going to equal to the time it takes to travel 660 miles. So that's the distance, 660. And now it's going against the wind, so it's the speed of the plane, 305, minus x. So the speed with the wind is the time it takes to go with the wind is going to equal to the time it takes to go against the wind. And now here, this is not like the other ones because we don't have anything added or subtracted, so we can cross multiply. So we do 910 times 305 minus x is going to equal to 660 times 305 plus x. We distribute. 910 times 305 is 277,000. and 550 minus 910x is going to equal to, now we distribute the 660. 660 times 305 is 201,300 plus 660x. Now this is not a quadratic equation. That means that we can just solve for x by moving all the x's on one side and everything else on the other. So I'm going to add this 910x over here, which would give me 277,550 is equal to 201,300 plus 1,570x. Now we can subtract this 201,300 and we get here 76,250 is equal to 1,570x. So divide. And we get that x is equal to 48.6. And this, remember, x represents the speed of the wind. So our units here are miles per hour. Let's try a few more. You hiked 6 miles up a mountain. For the trip down, you were able to walk 1 mile per hour faster. In total, the round trip up and down the mountain took 5 hours. What was your speed as you hiked up the mountain? So I always use the question at the end to figure out what my variable is. I'm trying to solve for my speed as I hiked up the mountain. So that means that x is going to equal to the speed up the mountain. Once more, which I have it actually down here when we can use it, time is equal to distance divided by the rate. So we are hiking 6 miles up the mountain. So the time that it takes to go up the mountain is the distance, which is 6 over x, because that's how long it takes me, or that's the speed that it takes me to go up the mountain for 6 miles. Now we are doing a round trip, so we're going to add how long it takes to go down the mountain, which is still the 6 miles, because going up and then going back down is the same distance. But the speed here going down the mountain is 1 mile per hour faster. So that's the speed that I was going up the mountain plus 1. And the total trip took 5 hours. So that's how we write this out. So this is the total time that it took to go up and down is equal to the total time it tells us, which is 5. And now we have, since this is addition, we need the LCD. My LCD here, if you just look at the denominators, would be x times x plus 1. So I'm going to multiply x times x plus 1 with 6 over x plus 6 over x plus 1 is equal to 5. Distribute. If I distribute this to this first fraction here, the x's would end up canceling. So we would just multiply 6 with the x plus 1. Plus, now when I distribute it to the second term, the x plus 1's would end up canceling. So we would only multiply 6 with the x. Is going to equal to, nothing would end up canceling here since there's no denominator. So we would just multiply 5 with the x and the x plus 1. Now we're going to distribute everything and solve. So this gives me 6x plus 6 plus 6x is going to equal to 5x squared plus 5x. We can combine these two 6x's. 6x plus 6x is 12x plus 6 is going to equal to 5x squared plus 5x. Now this is a quadratic, so we want to make the quadratic equal to 0. So I would subtract this 12x and subtract the 6 over to the other side. So I'm just going to rewrite that over here. So we have the 12x plus 6 is equal to 5x squared plus 5x. Subtract the 12x. Subtract the 6. So we get the quadratic 5x squared plus, oops, not plus, minus 7x minus 6 is equal to 0. Now here we have this quadratic, but we have a 5 in front of the x squared, which I cannot divide from every term. So you have two options here. You can either solve this quadratic using the quadratic formula, or we can factor using the AC method, which is what I'm going to do now. So in this particular quadratic, AC is equal to 5 times negative 6, so negative 30. And the two numbers that would multiply to give me negative 30, but add to give me negative 7, are negative 10 and positive 3. So I can rewrite this quadratic as 5x squared minus 10x plus 3x minus 6. And now we factor by grouping. 5x squared and negative 10x both have a 5x in common, leaving me with x minus 2. And 3x minus 6 have a 3 in common, so plus 3 times x minus 2, which leaves me with the factors 5x plus 3 times x minus 2, which if I solve for each one, I get that x is equal to, here in this first factor, we would subtract the 3, divide by 5, so negative 3 over 5, or 2. Now remember that x represents the speed of the mountain. Speed cannot be negative, so that means that my speed of the mountain is 2 miles per hour. Now let's look at this last problem. It says the difference in the average speed of two trains is 16 miles per hour. The slower train takes 2 hours longer to travel 170 miles than the faster train takes to travel 150 miles. Find the speed of the slower train. So here, first of all, if we're going to dissect this, this is the main piece of information here. The difference between the average speed of the two trains is 16 miles per hour. Difference meaning subtraction. So this means that if I were to subtract the speed of the faster train minus the speed of the slower train, you're going to get 16 miles per hour. Since the faster train is going to go faster, that's why we do the faster train first minus the slower train. So let's write that out so we can kind of just get an idea. So this is speed of the faster train minus the speed of the slower train is going to equal to 16. So now what we do here is we're going to have to write an expression for the speed of the faster train and an expression for the speed of the slower train. Now here I have here that if time is equal to the distance over rate, then the rate, which is the same as speed, is going to equal to distance over time, which is the relationship I was talking about before. If you have the equation that distance is equal to rate times time, then if I were to solve for rate, I would have to divide time, giving you that rate is equal to distance over time. Now let's get back to this. In order to write an expression for the speed of these, I need to assign a variable. Now, here what I'm looking for at the very end is to find the speed of the slower train, which is going to be this expression here. So x cannot be speed. X is going to be something else. And if you can't figure out quite what it is, think about it like this. The speed of the faster train. Speed is distance over time. The faster train travels 150 miles. So that's the distance. 150 over the time. Now, I don't know the time. That's the thing. So if I want to, let's say, find out what is the speed here of my train, you can either make x equal to the time that it takes for the faster train to travel, or x to be the time that it takes for the slower train to travel. Since in the very end I'm going to try to find the speed of the slower train, let's make x equal to the time of the slower train. So that means here that the time that it takes for the faster train is going to be the speed of the slower train minus 2. And we get this minus 2 because it says here that the slower train takes 2 hours longer to travel in the same time of the faster train. So if it's 2 hours longer, that means that the faster train is going 2 hours faster. So the time that it takes for the slow train minus those 2 hours, since it is faster. Now again, we're going to continue with this equation, right? So minus, now the speed of the slower train. The speed of the slower train is going to be its distance, which is 170 miles, over the time that it takes for the slower train, which we said x is going to represent the time of the slow train. And this difference is equal to 16. So now that we have our equation set up, we need the LCD. My LCD here would be x minus 2 times x. So now we're going to multiply this LCD to the entire equation. So x times x minus 2 times 150 over x minus 2 minus 170 over x is equal to 16. We distribute. So here the x minus 2's would cancel, so we would only multiply the 150 times x. Minus, now here the x's would cancel, so we would multiply 170 with x minus 2. And that's going to equal to 16 times the LCD, since nothing would cancel. Now we're going to distribute everything and see what we end up with. So we're going to distribute this negative 170, and we get 150x minus 170x plus 340 is going to equal to 16x squared minus 32x. I end up here with a quadratic, so we're going to want to make this equal to 0. But first we can combine these two terms here, and that gives me negative 20x plus 340 is equal to 16x squared minus 32x. So we can add the 20x over and subtract the 340. So what we would get would be the quadratic equation 16x squared negative 32x plus the 20x would be negative 12x. And then we would have to subtract the 340. So minus 340 is equal to 0. Now we need to factor. I have 16 in front of the x squared. Not every term is divisible by 16, but every term is divisible by 4. So we can divide everything by 4 just to make it easier. You can also think about it as if you're factoring out 4. That's not going to affect my answer anyway, so I'm just going to get rid of it. 16 divided by 4 is 4x squared minus 3x minus 85 is going to equal to 0. Now here we're still going to need to be able to factor, or you can always use the quadratic formula, but I always like to make sure that we can practice factoring. So because we still have a number in front of the x squared, we're going to have to use the AC method. So first we need what is A times C. 4 times negative 85 is negative 340. And now we need to figure out what two numbers would multiply to give us negative 340 that would add to give us negative 3. Which those two numbers would be negative 20 and positive 17. Negative 20 times 17 is negative 340, and negative 20 plus 17 is that negative 3. So now we would rewrite this quadratic, replacing the negative 3x with these two numbers. So 4x squared minus 20x plus 17x minus 85 is equal to 0. Factor by grouping. We can take out a 4x from both of these terms, and we get 4x times x minus 5. With the 17x minus 85, we can factor out a positive 17, leaving me with x minus 5. So my two factors here would be the x minus 5 and the 4x plus 17. Now what we need is we need to solve for x. So here we get that x is equal to 5. And here we would subtract the 17, divide by 4. So negative 17 over 4. But keep in mind that x represents the time of the slower train. Time. So we cannot have negative time. So x is equal to 5. Now we think we're done, but we're not quite there yet. The question was asking for the speed of the slower train, not the time. This is the time of the slower train. To get the speed of the slower train, that is represented by this, the 170 divided by x. See, speed of the faster train minus the speed of the slower train. This ratio here, this rational function, represents that speed. But we have x, so we can plug it in and we would get the speed of the faster train. So the speed is going to equal to 170 divided by 5. And when we divide, we get 34. And my units would be miles per hour. And that's using rational functions to solve these word problems.